This is the last section of notes about exponential functions, and this is not so much about exponential functions, it's just making sure that we understand how we can kind of differentiate which function we're looking at. So we're going to look at some key characteristics of the equation, of the graph, and if you had a table of values, what you would be looking for to know which of those parent functions is kind of like what you're dealing with. So let's talk a little bit about linear functions. The parent function for a linear function is f of x, or y equals x. And that's just our straight line, which I'm going to really struggle with here on the screen. But it has a slope of 1 and a y-intercept of 1. Oh, this isn't going well. And is, generally speaking, a little bit like that. Our quadratic function is f of x, or y, equals x squared, and that's our parabola that sits at 0, 0. And as I move out from my vertex at 0, 0, if I go out 1, that means I'm plugging in a 1 or a negative 1 for x and squaring it. So then 1 squared is 1, so I'm going out 1 and up 1 to find more points on my parabola. Sorry, drawing is very hard on this screen. And then if I go out from my vertex of 0, 0, and I go out 2 in each direction, I would square 2, or negative 2, to find my y value. So if I go out 2, I go up 4. So I have points up here and right there. If I went out 3 from the vertex, not the previous point, from the vertex, that's 3 squared, or negative 3 squared, which is 9. So if I go out 3, I'm up at 9. And then we can draw in that U-shaped graph. Oh, goodness gracious. We can try to anyways. Let's start over. Look at the answer key in Google Classroom, because it's going to be a much better graph than I can do on here. That's terrible. And I would take points off if you drew yours like that. But on the keypad, it feels impossible. All right, and then our last one is our new one. It is that f of x is equal to b to the x power. Our exponent's up there in the exponent, and we have an asymptote here at 0, and our graph comes across, crosses at 1 on the y-axis and goes up. And how fast it grows has to do with what the b value is. So those are the general shapes of the graph. So if you're looking at a graph and you see a straight line, you know it's a linear function. If you're looking at the graph and you see a parabola that doesn't look as ugly as the one I just drew, you know it's a quadratic function. And if you see this not symmetric curve either growing or decaying, coming down this way, you know it's exponential. So when we're identifying them and we're looking at the equation, we know that it is a linear function anytime x is to the first power. If x does not have an exponent, it's a linear function. Whereas for a quadratic function, you know that it's a quadratic function anytime the highest exponent on x is 2. So anytime x is squared. Or if you were to simplify if it were in factored form and you were to multiply it out and simplify it, it ended up having a highest exponent of 2. Exponential functions are pretty easy to spot because the x is always in the exponent. And that lets us know we're going to see that sharp curve up or down. The graph of a line is pretty easy because it's a straight line. Graph of a quadratic function is always going to graph a parabola. Parabolas are symmetric. And exponential functions are always going to graph a curve that is not symmetric. So sometimes you'll see quadratic functions referred to as a curve, but it's a symmetrical curve. The parabola is doing the same thing on one side as it is on the other. Exponential is just growing. There's no symmetry to it. Like there is to a quadratic. Okay, sorry. So when I look at these, oh wait, we still have to talk about tables. So for the table, if I'm looking at a table of values, as the x value changes in the same increments, we're going to notice that the y values increase by the same amount also. Just that steady growth that just keeps moving up using that slope to give us that straight line. For a table of a quadratic function, that one's a little bit harder to find, but it has a constant second difference, and I will explain what that means. This is something you'll use a lot when you get into pre-calculus and calculus. But if you look at the difference of the y values between, like x has to be increasing by the same amount. But if you look at the difference between the y values for a quadratic, if you just look at that first amount of difference, you're not going to see a change. So like, for example, in this table down here, or you are going to see it different, like 18 minus 6 is 12, 6 minus 2 is 4, and 2 minus 2/3 is 1 1/3 or 4/3. So that's not the same. But then if you took the difference of those differences, so this was 12 and that was 4, that would give me 8. And if I got the same difference when I went from the 4 to the 4/3, then I would know that it's quadratic. The easier way to do this when you're taking your SOLs and your common assessment, put the table into Desmos and look at the points and see, are they in that parabola shape? Are they in a curved shape like an exponential function? All right, and then the last one for exponential functions, we can figure out from the table if it's exponential, because when I divide the y values, like one y value from the next y value, I'm going to get the same amount each time. Probably didn't phrase that really well, but we let's just jump down and look at this example right here, because this one's going to work out like that. So if I look at my neighboring y values in the table, because all these x values are increasing by 1, if I do 18 divided by 6, I get 3. And if I repeat that with the 6 and its neighboring values, so 6 divided by 2, I get 3 again. And if I were to divide 2 by 2/3, I'm going to get 3 again. And so since that quotient is the same for all three of them, I know that this is an exponential function. All right, so that's kind of explaining what that's supposed to mean, but I was having a hard time coming up with good words. Looking at these other two, if I have the graph, I look at this, I see a symmetric curve, easy peasy, that's quadratic. Tables are the hardest, graphs are the easiest. Functions are kind of in between. If I look at this, here's my variable x, it is to the first power, that tells me this is linear. But remember, if you're ever unsure and you are taking an SOL or an online test, you could type this function into Desmos. You're going to see that graph of a line. You're going to know it's a line. So now you are ready to do the sort, where you are sorting the various graphs, functions, and tables into linear, quadratic, and exponential functions.